Okay. So the next thing we're going to look at is chapter two. We're going to start with significant figures. So significant figures, and certainty. We're going to start talking about certainty. Basically, um, science is pretty good at using a lot of big and small numbers, right? We have things like the atom. This is a very, very, very small number. Look at all these zeros in front of the where the numbers start. That's a really, really, really small number. Um, we also have the uh, really on the other end of the spectrum, like huge numbers, massive numbers. What is that? 91 million miles? That's a lot. That's a lot of space, so to speak. And so, we have to ask ourselves, do all of these zeros matter every time? Like there are so many. When we report scientific data, we do report the measured digits, but sometimes there will be other digits. If you've ever hit the pi button on your calculator and then just hit enter or whatever it is, you will see that digits can go on forever. So how many of them are significant? What is your uncertainty? Like when are you sure you have a number? When are you unsure? Um, well, first, let's see what we can do about some of those zeros. So, Um, we're going to go through exponents just briefly, so then we can talk about them because we are going to use these in scientific notation. So if we take a look at this, the positive exponents, um, for positive exponents, we can take a look at what that would look like. If we have 10 times 10 times 10 times 10, that's the same as saying that we have 10 to the fourth power. Each time we multiply by another 10, we are going to add 1 to the scientific notation. So that would be 10 times 10 times 10 times 10. Again, that would be 10 to the fifth, etc., because there are five tens present. And so but for this case, we are not going to do that. But this number isn't exactly clear. It is clear to somebody who's familiar with scientific notations, but if you're not quite, then we can kind of write this out as a regular number. 10 times 10 times 10 times 10 ends up being 10 with four zeros behind it, like that. So that would be 10,000. Similarly, over here, take a second and pause the video and then see what you would write in that box. Okay, cool. So let's do it like this. 10 times 10 times 10. There's going to be three tens there, right? Three tens are going to multiply together to give 10 to the third right there. And would you look at that? It's going to be a one with threes. Oh, no. That's what you get for writing and talking at the same time. One with three zeros behind it. So the number of zeros that are following this one and this number up here are absolutely linked. We will come back to that in a moment. Um, okay. If we look at negative exponents, this is like dividing rather than multiplying. We'll take one and divide it by however many tens we have. So right here, we have only one 10. So that would be 1 divided by 110 gives us 1 or 10 times 10 to the negative first power. And we could even rewrite this like this. 10 to the negative first power is going to be 0.1, like that. Now take a moment, see what you can do about 10 to the negative third power. Is that going to give you, well, what answer would you predict from that? Okay, cool. Let's let's try it out. We have 10 to the negative third power. So there are a few different ways of writing this. I will show you. The first way is going to be like this. 1 divided by whatever we would write. Oops, sorry. 1 divided by whatever we'd write over up top. So up here you have 10 times 10 times 10. You could write that down there. That'd be 1 divided by 10 times 10 times 10. If you were to do all of this math out, you would get 0.001. So this is one way to do that, but there are a couple more. You can take all of the things that these are equal to. So 10 times 10 times 10 is equal to 10 to the third. So you could also put 10 to the third down there, and you would still get the same answer. That's going to be 10 to the negative third. 1 divided by 10 to the third is 10 to the negative third. You could also put, well, I'll keep that and we'll put it over here with the rest. You could also put 1000 under there. So 1 divided by 1000. That's going to also give you the same thing. That's because all three of these are equal to each other, right? And so you might notice, well, this is 10 to the negative 1. There's 1 0 here. Interesting. Let's keep that in mind. 10 to the negative 3. There are 3 zeros here. Fascinating. Let's keep it in mind. And let's move on to scientific notation. So, scientific notation. This is the format that we use for scientific notation. Over here, um, this is going to be your first digit. You take one number and put it to the left of a decimal place. Make this a little smaller. One number, put it to the left. All your other significant numbers are going to go to the right of the decimal place. All other significant numbers to the right. Oof. Okay. You then will have a multiplication and then a 10 and an exponent. So your exponent is going to be dependent on which direction you're moving in. This would be the number of places to move the decimal. And you're probably like, Dr. Keto, what do you mean by move the decimal? Well, let's find out. We have this number right here, 638,902. Okay. What we're going to do is we're going to pretend that there is a decimal here. Even if there's no decimal there, that's where the decimal would be, right? The decimal is going to go right at the end of that number. We are then going to put it into this format. And so how many times do we have to do that? Let's count them. In order to get it there to be one decimal, that's going to be 1, 2, 3, 4, 5. So we end up with this 6.38902. And we had to move this. Let's see, 1, 2, 3, 4, 5. That moved it 5 times. So the number that I put up here is a 5. It's going to be a positive 5. So we're going to move the decimal number over to get one number by itself. We'll then multiply that new number, this 6.38902, instead of 638,902 with the decimal at the end, by an exponent. The exponent number is going to be the number of places that you move it. If the original number is going to be greater than 1. So this number absolutely is larger than 1, much larger than 1. You are going to have a positive value in the exponent. If this number is less than 1, right? It is going to be way less than 1. Um, then you are going to have a negative value up here. So I gave you a little hint. Go ahead and try this second example on your own. See if you can get it. Okay, cool. Let's try it. So we're going to we're going to see how many times we have to move the decimal in order to get one number on the left. That's going to be one, two, three, four, five. Okay, excellent. That is going to be five. So that means we have 4.5 right there. The four is on the left of the decimal place, the five is on the right. We know this number is going to be negative, so I'm going to put a negative out here. And we know that we had to move it one, two, three, four, five places in order to do that. So that's going to be a negative five right there. And so our answer for that is negative five. Now, there is something else I want to show you. This takes a little bit of practice to get right if you've never seen this before. So there will definitely be homework problems on this in the mastering homework. Um, what I would suggest is taking a look at it this way. So, the way that you can do this quickly, basically, this is the way that I do it, is I will see what number is the furthest number that I need, or whatever number needs to go to the left of the decimal place. And then I will just count the number of digits that there are between that number and the decimal place. There are five digits, and so that gives me a five up there. For this one, I count those numbers and I always, always, always put a zero to the left of the decimal place if you have a number that is less than one. Uh, that way I can include that in my count. This is going to be one, two, three, four, and then including that number to the left of the decimal place, that's going to be five. So I know that my number is going to be five. I still have to have use this rule. If the number is greater than one, the exponent is going to be positive. If the number is less than one, the exponent is going to be negative. Um, so that's the way that I would look at this. Now, the other thing is, if the original number is greater than one, the exponent is positive. If the original number is less than one, the exponent is negative. There's something that I do want to point out here. So what that means is whether or not the number itself is a positive or negative number, if the magnitude of the number is greater or less than one, then the exponent is going to change like that. So let me give you an example. Let's say that we have negative 618.3. Oh my God, I'm trying so hard not to do one of the other examples, but 61830492122. Okay, big number, right? Decimal place is right there. What I'm going to do is I'm going to do this the way that I know how to do it, and I'm just going to count the numbers that I need. Or first, I'm going to find the number that's going to go to the left of the decimal place. Even though this is a negative number, this number right here is still going to go to the left of the decimal place. And so I'm going to end up with 6.18304922122. Now, what I can do is count the number of digits that followed that six. And I was talking and I didn't count. Okay, one, two, three, four, five, six, seven, eight, nine, 10. So I'm going to end up with a negative number still, and I'm going to put a times and then 10 to the 10. So even though this number is technically less than zero, I don't care what the actual sign is of the number or less than one. I don't care what the sign of the number is. I only care about the magnitude. So not the direction, just the number itself. Yeah. Okay. If you have questions about that, you can talk to me about it. You put it in the discussion, and I will explain further there. This is how we are going to do this part. So if the exponent is positive, to get out of scientific notation, this is how we would go about doing it. Scientific notation, we have um, these, by the way, these are those, that's the problem number. 3.44 times 10 to the sixth. This tells you the direction and the number of steps to move that decimal place. If it's positive, you're going to move it to the right. So we're going to move it to the right 6 times. We end up with um, one, two, and then we can imagine four more. So we'll end up with 3.44. I'm just going to do it over here. 3, 4, 5, 6, like that. And then everywhere where there's nothing, we're going to put a zero in, like that. I'm going to erase all of those leaps and the decimal, and that's what we get. We get 3440000. Even put in some commas there, but that's our number. 3440000. Now, if you think about it using my method, you get um, a 3 followed by 6 digits. 3, 1, 2, 3, 4, 5, 6. There you go. Let's try it with this one. So 2.894, we need to move that to the left um, 3 times because the exponent is negative. So we'll move the decimal over to the left. So that's going to be um, 2. Let's do it in the same color. We have 2.894. And we will move that, move that, move that. I'm going to place zeros everywhere, and I'm going to put the decimal in now, and I'm going to put a zero over here. Now, you might have noticed I didn't put a decimal there. I will explain why when we get to that section. But we have 0.002894. We can erase that old decimal and all the numbers and all the hopping things. And you might notice as well, -3 over here, there's one, two, three zeros before the number that we're looking at. Okay. All right. Go ahead and pause it here and give it a shot. Okay. So we have this number right here. The decimal has to go right there. Right there. There's going to be 1, 2, 3, 4 numbers to the right of that decimal, which means that that's going to be a 4. We have to hop to the right, which gives us a positive number. So we end up with 7.376 times 10 to the positive fourth. Do the same thing here. The decimal needs to go right there. There ends up being 1, 2, 3, 4, 5. Zeros before the number that needs to go to the left of the decimal, including the zero that's before the decimal point. That gives us 3.856 times 10 to the number of zeros there are, which is 5, and it's going to the left this time, so it's negative. Scientific notation to the number, we're going to do the exact same thing. Um, And we actually did do these ones already, I believe. So we do know this is going to be 3, 4, 4, 0, 0, 0, 0 with 6 numbers to the right of yeah, this turns into 6 digits to the right. Over here we'll do the same thing, but now we're going to the left. That's going to be 0.000000. Um, so 5 zeros, and then the sixth one right there. 2894, like that. Okay, I'll see you in the next video.